I'm Russell C. Stanton, Russell, C for Crom, Stanton, Stanton.
Great. And you're here because we want to learn more about your role in the Manhattan Project and DuPont's role there. Wondered if you could start just by telling us a little about yourself and where you were born and how you got involved in engineering.
Well, I was born in Elephant Butte, New Mexico. My father was an engineer with the Bureau of Reclamation, and they built a dam there. I was born in a wall tent at the site, as was my sister. And that was back on August 1st in 1915. I graduated from the University of Delaware in 1937 and with a Bachelor of Science in Civil Engineering. I went to work full-time with DuPont. I say full-time because I did work part-time during summer vacations with DuPont. Lost my train of thought. The work that I went into full-time, I was on various plants for the DuPont company, ranging from textile plants to ammonia plants to projects for the government for powder and nitric acid, that type of thing. My introduction to atomic energy work was actually unbeknownst to me. In those days, you got instructions to report here, report there, and along the way, you might find out a little bit about why you were going, but usually you had to wait until you got there and find out for yourself. But I had trips to Oak Ridge, which our part of Oak Ridge was called Clinton Lab, and there we had a air-cooled semi-works, you might call it, of a pile for production of plutonium, which I had relatively little to do with, except to see what was going on. My big project there was what they call it SMX, and I never did figure out what the S stood for, but it consisted primarily of what turned out to be a couple of B blocks, as we called them, and the equipment in order to push high volumes of water through the tubes to measure pressure drop, to measure how big the tube needed to be, how heavy the wall, and so on. That actually required very little time, but I still didn't know what it was all about. I got instructions all at once to report to Wilmington. Was told I was going to report to Hanford and given tickets, and wound up at Pasco, Washington, or by train at about 4 o'clock in the morning. And I was one of the lucky few who had a reservation at the hotel in Pasco, which mainly amounted to being a place where you met a driver who would take you to the offices at Pasco, where I was at before 8 o'clock. I never really, I don't know whether I ever saw the room, but anyway, I had a room, which was unusual. And that was the last time I had a real room for almost a year. And when I got there, I found out that I was the assignment for my assignment was for the building the 105 buildings there. And the 105 building is the reactor building. And when I say build the 105B reactor buildings, that means not only the structure which housed the reactor, but the reactor itself. Very few people realize that there were no reactors per se. You had to make your own reactor. And as turned out later on, it was fortunate that it could be done that way. My introduction to the job, I met Gil Church, who was the project manager. He had an assistant, T.L. Pierce. He had an assistant for field work, who was Grant Bubb. There was another assistant for the building the barracks area. There was a field superintendent, Les Grogan. He had an assistant, Bill Redmond. I had, and there was a area engineer who looked after all the 100 areas. And then I came in and had the 105B areas, which put me number 7 from the top man at the site. Each of the 100 areas, for other than the 105 buildings, had a division engineer assigned for all the other facilities that were required to make the reactor work. The only facility that existed when I got there, and I got there very, very late in the job because the first 6 months of being, everybody could be hired, and there was a very extensive recruiting force in the field. Was used to build barracks so they could build some more barracks. And they finally reached a point where they could spare somebody off of the barracks to do other work. And from then on, of course, the job blossomed out. Hanford included, it became the third largest, Hanford and its barracks, the third largest city or country or town in the state of Washington. And there were organizations to build the complete infrastructure, railroad tracks, power lines. The rest of the 100 areas were for producing sufficient water to cool the reaction going on in the 105 buildings. There was a village there that was being built, a commercial facility in the village. And following the 105 process building was a 200 area, which is an area to separate plutonium from the other products of the nuclear reaction or nuclear reaction, and separate out the plutonium. And for the first run on the thing, they produced enough plutonium that it was the size of your fingernail and could be carried down to Los Alamos for them to start their work. In somebody's vest pocket, it had a little envelope or something in it. That from then on, of course, the shipments were bigger. But all of the other parts of the Hanford engineering works were there to be able to run the facilities if the 105 building produced the plutonium that it was supposed to do. And I think you'll have other people here that will talk on this. The chronological start, which I mentioned in one of my letters, was a letter from Mr. Greenwald, Crawford Greenwald, reporting the results of the initial atomic reaction in a facility under the stands in Stagg Field at the University of Chicago. And the output of that facility was very minute. It later described it as where normal plant scale-up was on a basis of 100 to 200 times the initial facility. At Hanford, the scale-up was 1 billion to 1. I had never heard that number until just recently, but that explains why the 105B building was built in such a short period of time, because there was no information from which to build it. I didn't get there until October of 1943. Mr. Greenwald's letter, December 2nd, 1942. I got there in October of 43. And other than getting the equipment to manufacture the things that were known to be needed, there was nothing else. There was no other design available to start work in the field until, the initial work for grading, general grading, was in October, and the actual information for putting in foundations, which were 28 feet deep for the reactor, didn't come until early November, probably. But the core of the reactor at Hanford was graphite. And there were only 3 sources of graphite at the time. I can't remember all of them, but all of them were in the business of producing electrodes from graphite. And the process involved an extrusion of material which was essentially pure graphite, but there were other impurities that they couldn't keep out as they made the mixture and extruded it, and then cured it in a very, very high temperature, which left the surface of the bar that we got covered with carborundum-like materials, which were extremely difficult to do anything with it, and particularly to get machined off. So we had the problem of refining what amounted to be woodworking joiners into a piece of equipment.
Must have been quite a scene. 50,000, building a city for 50,000 people. Talk about what, your first impressions of walking into this incredible, scene, because it was really the biggest civilian construction project maybe ever at that point, or military, or, and talk to Cindy as you do.
A question's been raised that, what was it like to walk into a barracks area like was being built at Hanford? And I can honestly say that I very strictly stayed away from ever having to go into the barracks area, except for general services such as a haircut. They had, I think, 50 chairs and barbers set up there, and my first experience was with a superintendent that I had brought into the site, and he walked up and down the line and picked a spot and watched one of the barbers and said, "Aha, that guy's a mechanic. I'll have him cut my hair." So Jake was a real knowledgeable mechanic, and that's where I got my hair cut too. But otherwise, my association with the barracks was very limited. I had a procurement supervisor who came from Chicago. I hired him through the employment office on site, which you do by walking in. You put your requisition in and wait to have somebody be interviewed, which never happened. So you go up and see what's going through and what they have in file. And Leo Franzel happened to be the fellow that looked like he'd be most qualified. And Leo came from Chicago and heard from Bob Burden, who was the assistant manager on the site for building the barracks, that things were going pretty good, except there's a lot of unhappiness among the people that had to live there because there were no sweets, no candies, no bars, and that sort of confection that they were normally used to. So Leo asked him, well, would you like to have some? And Bob said, sure, but I'd be happy to get some. So about a week later, Bob got a call. There were some candies for him out at Central Shops here, wherever all the freight came in. And so Bob says, okay, send it over. He said, well, the fellow called him and said, well, there's 2 carloads of it. And Bob said, 2 carloads, and got a hold of Leo. So, well, you said you'd take all I could get. And so Bob said, well, that would be fine for a while. But that was my second contact with the barracks. While I was there, when I got there, Jake and Stu and myself lived in what they called tract houses, where the people lived who sold their land to the government to build Hanford on that site. I think there were 550 acres, I don't know how many, but quite a few acres. There were quite a few tract houses. So we were fortunate enough to get into a tract house that was relatively close to where we needed to be, and they were quite elaborate. If their bedroom was real big, you could get 2 tiers of bed, a upper and a lower end on both sides of the wall. If they weren't that big, you only got 1 tier in, and they had enough blankets and things, and essentially no closet room. And that's where you lived until there were houses available.
Hang on just a sec. You worked on the building of B Reactor? That was
Yeah, he was-
105.
Had all the 105 buildings, and at that time there was 105 B, D, and F. And B, of course, was the first building that we started on, and did everything we could to get that building operable to make plutonium.
Well, just for briefly, could you go back to the machining of the graphite? Because from what I understand, that was really those blocks of graphite were all hand machined, right?
Yeah, yes, they came in pallet loads as they came from the facility that I want to say baked them, cooked them, with their layer of carborundum on it. The preliminary work that had been done at the Clinton lab had been on joiners, but it hadn't been very successful because they could only cut 2 or 3 blocks. They had to put new blades in the cutting head on the joiner. So that was one of the first jobs. Well, I would go back, the 101 building had the foundations poured, the floor area poured, and they were waiting for structural steel to finish the building. Part of the building it was only a 1-floor building, 1-story building. had a roof on it. That had to be finished, so we have a place to bring the I can't do
I'm gonna give you a
joiners,
right?
bring in the joiners. The other buildings that we had to build in order to make the materials that were needed to build a reactor were strictly a temporary construction type of facility. And 101 was one of the buildings that was necessary because there was 800,000 pieces of graphite that had to be machined for all three of the 105 buildings. The other facilities that we made on site or provided on site were to make side shields for the pile. The two ends of the reactor had B blocks, what were called term B blocks, and they were very accurately made and machined because they were the areas where the tubes were introduced into the pile through the shielding into the graphite and out the other end through B blocks on that end. And these blocks had all of the fittings on, were equipped to take a lot of fittings for the introduction of water into the front end and to the release of water on the back end. The shielding for the remainder of the pile was built on site at White Bluffs in shops, temporary buildings, where the plates to it, the shielding basically consisted of layers of alternate layers of steel and hydrogen. The steel was steel plates. The hydrogen was not plywood, but a thin shield. I can't think of the name of it now. Anyway, there were bundles of that material had to be put together and be compatible with the matching sheets of structural steel. And that there was 40 feet of shielding on both sides. One side had the control rods passing through the shielding. The top shielding had control rods and emergency rods coming down through it. And they were all facilities that had to be made. Partway through in the initial planning, we hadn't actually gotten very much started. We were told that nothing could be used or that in processing the material that would introduce certain strange chemicals or chemicals that they needed to know what all the chemicals were, and in order to do this, we had to indicate what the lubricants were going to be and so on, and wound up providing a laundry. We had to build a laundry that would equip every day every mechanic that would be handling graphite or anything that graphite would touch in this protective clothing. One other requirement that suddenly came in was that we needed a tube shop because each tube coming in needed to be pressure tested and measurements taken to be sure that there were no weak spots in it, and a quick flow, and the tube had to be cleaned again to be sure that no foreign material had been introduced, particularly on the outside of it. They were the principal areas that where we had to make facilities in order to assemble the pile.
I've got a quick question for you. What was it like at the time? There weren't a lot of blueprints. I mean, this was the first plutonium creating reactor, breeding reactor built, right?
Right.
So, I mean, what was the attitude at the time? Greenwald was, and DuPont in their culture, you know, tended to overbuild everything. So how much seat of the pants engineering was being done here? Because this was really the first go-around, wasn't it?
Yeah, this was no other nuclear reactor had been built. This was the first nuclear reactor that had been built. I think you're referring to an episode or to a shock that everybody had when they attempted to start up the pile, which was in September, I believe. They pulled the rods and worked the pile up and watched their instruments and could see the level of production, which is measured in kilowatt, rising. And then suddenly that evening the thing dropped and just stopped. And that was totally unexpected, and for a long time it was unexplained. And the reference you made to Mr. Greenwald was when he got into it from some experience that he had had either in processing the data that was generated by the physicists to information to be used by our design people, remembered that xenon was one of the products that was produced, and xenon in sufficient quantity or in enough quantity was a poison to the reaction. And because the next day, even though nothing else had been done, the pile would come back up in level. And the answer to that was the initial design that came out had 1,500, well, had 2,004 tubes, which is the way it is now. But when it was passed on for approval by the MetLab people, they said you don't need that many, you only need 1,500 tubes. And I don't know how, why, or who, what, the extra 504 tubes got provision for them, got built into the pile. We had B blocks for them. We had the graphite was machined to take tubes so that when this xenon phenomena occurred, all that was required was to load those extra 500 tubes with uranium and restart the reactor, and everything has worked fine since then. So is that the
Yeah, that was. Now look at. Be sure to look at on this side of the camera when you.
Okay.
But tell me just in general how people felt about during the construction. I mean, did you have the idea that it would work, because you were really doing a very, very, very new science here. I mean, this was cutting edge, and yet there was an attitude that it really had to work. So was there a lot of checking, or how did you guys feel about that?
Well, the way the people were recruited, the way they were handled on site, and the information that they heard when they were on site certainly convinced anybody that came in that this was something very, very unusual. I don't think there were 1% of the people actually working on the site, the journeyman mechanics that knew what it was all about. They knew it was urgent and important to get it done, and they worked that way. A lot of people have been concerned, well, how did you overcome the usual problems that are associated with labor unions? And we didn't really have very many problems with labor unions, but Frank Mackey, who was manager of construction there, had an excellent working relationship with all of the trade unions, and was able to, we just didn't have labor problems. And the men, I guess, knew that what was being built was going to be delivered by air because all of this was being done so we didn't have to invade Japan. And they had a day's pay to buy an airplane, and this is all a voluntary effort on the part of the men that were there. Well, I guess actually the initial bomb had been dropped, but they contributed money to have a plane, buy a plane, and it has a name, I can't remember it now.
Can you just explain that again? Because I think we'll want to use that about how there was an effort to collect a day's pay from every employee that was contributed.
That happened, I think, probably after I left the job. I know it happened, but when I got the 105 buildings where they were all operable, I was assigned the job of building a fish hatchery. So I was kind of, and the fish hatchery was off to the side and getting that. But I do remember the publicity that came with the men on the plant, and there's a picture of it, I think, in history, not a history, but a investigation by Harry Thayer in his book. He has a picture of this plane being given to the military with a name, and I can't remember. Oh, I think it was a day's pay.
Yeah.
My memory.
Was the fish hatchery, was that part of the environmental program, the environmental monitoring program, where they were trying to determine whether, there were radionuclides getting into the waste stream and so forth?
That is, I guess I should say, for the 100 areas, that was the environmental program, and it came after the 105 buildings had been completed. And it was not a very elaborate facility, but it had to be a facility where they could get both the Columbia River water into the structure and the effluent water from the pile so that they could measure the difference in it, and they also had a place where they could make little fish, and all ranges of fish could be exposed to this to see what happened to them. I imagine a lot of this was protective movement, and a very sensible movement, but it did come very late, and it was not really that big. It was, the money involved was very small.
You talked about the health.
Okay.
Okay, maybe we can pick up on the B reactor some more. You were telling me earlier that one of the reasons you were able to build it so quickly, not the phone, but how you were able to build your own staff. So maybe you can tell us about that as a factor in how you were able to build it quickly because you were able to choose the right people for the right jobs.
That's the one thing that throughout the job that the 105 area could never use as an excuse that we're short of manpower. From the time I got there, I needed to build a staff quickly because I was the last one in the management position to get on site. And I had worked over the few years that I was working full time before Hanford with a number of people from Bell, where a lot of high pressure work was done, and other sites that I had a great deal of faith and confidence in. And Jake Ruffner, Carl Hasty, Stu Klein, Charlie Bossert, and I don't know, and the people then, by going up and being able to pick them out of the people being interviewed at the time that went to the employment office. I was fortunate in the people I picked there that they all turned out exceptionally good. So that I was able to build a staff very, very quickly. I mentioned, I think, one time there was no place to have headquarters. I had to make headquarters, so 105B building, which part of it had been completed enough that there was roof overhead. I made my office, and the office furniture constituted a plank supported by a couple of nail kegs, and the seats were the same thing. And you had to get phones in. Well, I could finagle that pretty good. But to get furniture, you got to be an almost impossible job because everybody coming in wanted furniture. And I needed somebody to take care of things. When I wasn't there, I was out in the field. The 101 building was maybe 5 miles from the nearest 105 building. And when I wasn't there, people called, and so I had to have, or felt I needed very much to have a secretary. So I went over and interviewed the people that were in the employment picture at that time, and a young girl named Marlene Hinchy, I guess had just graduated from high school business course or went to business school or something, but she was not very old. And she became my secretary. And because we didn't have enough space in the 101 building for the storage of all the graphite, machining all the graphite, everybody, I had an office, and Arlene had an office, same office. And the thing I was working up to is the bill on people. The usual way of DuPont running their jobs, the plant manager and his assistant were the people on the job that called the shots. Well, it so happened that at the stage, very early stage, one of the first things I had to do was establish required dates for what equipment was coming in from the outside. And there was, even though we made the reactors, there was still a lot of equipment to be made outside and brought in. And somebody had protested one of the required dates that I had put on our equipment list. And so one of the assistant plant managers called on me and said that we'd have to change that date. And I said, well, that's fine, but I can't change it. And so we went round and round, and things got warmer and warmer, and the poor gal just didn't understand what was happening, so she had to get up and leave. But that was the way the organization was set up and run, that if I had the people there that I needed to do the job, and for somebody sitting in a chair half a mile away to say that I had needed another date, a different date, and I didn't need that help, and I couldn't use the equipment when it was coming in there, and at least and stay on schedule. So that's the ability to hire or to have or to transfer in people that you knew could do the job was a big asset.
Did you win that battle?
Yes, ma'am. The next morning, the gentleman called on the phone and said, Russell? I said, yes, sir. That matter we were discussing yesterday, this turned out to be just a discussion. I've told them we're going to go ahead as you have told them to do. So that was the last time that happened. Of course, the other experience we had to get rid of the nail kegs and the planks that became a desk. One of the people that I brought in, Charlie Bossard, said, Charlie, we can't go on this way very long. We had an order in for the furniture that we needed to for our staff to sit on minimum. And I said, how about getting us some furniture? And he said, well, how much you want, how much you need? I said, well, you find the source and we'll tell you how much to bring. So he, again, caught 2 carloads of furniture coming in and brought 2 carloads of furniture down. We had a lot of storage area in the building and just took what we needed to give everybody a place to sit and work. Put the rest in storage because we had more coming. We had the offices out in the area to equip with furniture. And I had another call from the plant manager, our construction manager, and he asked if we're having a problem with furniture. I said, no, sir, we're doing pretty good. He said, well, could you help so-and-so out? That's what you'd like to do, Gil. That's what we'll do. So we eventually reached a point where we never had a furniture problem, and as long as it lasted, we were able to help other people with furniture too.
Why do you think this worked? This was kind of a special time, and say an undertaking in this day and age of this magnitude, with that kind of speed and that kind of new technology thrown into the mix would be, people think it's just about impossible. But why did this work? I mean, was there an attitude? Was it the time? Was it the organization? Was it the war? Why did Hanford work so well?
I think that's a good question. There's a lot of people. Well, Harry Thayer spent several years trying to find out, because the schedules that we made there have never been repeated, never been duplicated any place, and never even been questioned after Harry made his investigation. But I think generally we don't take no for an answer. If this is what we need, this is what we do. And the responsibility of what we do had to be foreseen. You couldn't get the job done and say, well, now what are we going to do next? There always had to be something that was waiting to be done. We couldn't get structural steel to cover 105 building. And the 105 building is where all of our work centered. So we wound up, I went out, and Bev Sneed was the president of Virginia Bridge, and he understood, but he said, I can't make the steel, but we'll get it to you as soon as we can. Well, how long is it going to be? It's going to be at least 3 or 4 weeks. So what do? We were approaching a point where we had to, if we're going to keep working on the building, we had to cover it. We had to have a place that we could do work, and not have sand and any snow, if we happen to get it, come in on top of us. So we built a building over the building, over that part of the building where we were working. And I think people were impressed by that the job was important enough that we would go to that extent to build, put a shelter over so they could keep working.
How about some general statements about Hanford and the success that you had? I mean, and how proud, you must be very proud of the fact that you were involved in it. And be sure and talk to Cindy over here.
Well, Harry Thayer got involved in this because he was with Kaiser Engineers, and he would go to engineering meetings, and the discussion would come up about the schedule, and every people would, that's a lot of baloney. And Harry would say, well, I don't think so. I don't think that's right. And for anybody that's been exposed to construction work and to listen to the time intervals that were used or occurred at Hanford, it is unbelievable. And I guess if people know anything about engineering, they know that it is very, very much out of the ordinary. And Harry had gotten involved with people on some airfields, and in current times they were coming back, and he was getting memos from them where they were going to take 2 years to do something or 3 years to do something. And he sent him letters and told him, what do you mean? You had them something that was needed badly. And said, here's a way to get it done. And mostly there was no government interference. I mean, I'm not trying to point the fingers at the government, but from the day I got there, or the first week or month, I guess, that I was there, a representative from the Corps of Engineers called on me and introduced himself and said that his responsibility to the Corps was to keep them informed and advised on how the reactor building was going. And I said, well, you tell me what you think you have to know, and I'll see if we can find somebody that can put together. He said, well, all I need to know is whatever you have to provide to your management, if you don't mind, give me a copy of it. So that's the way we handled the Corps of Engineers. And that's the extent to which we had any interference. We had no interference whatsoever with the Corps of Engineers. And I don't know of any other government jobs that we were ever involved in, and we were involved in quite a few before then, where we did not have some government interference. But there was none. And in fact, they were very helpful in a number of cases when we just hit our heads against something. Frank Creedon's an excellent example. They go to Frank and say, Frank, whatever they want, you get it for them. Frank Creedon, I guess you know, is a manager of the production board for the government. He and his office allocated the short materials that were not readily available, and he would issue an order, and that's where they would ship the materials. Frank later became plant manager there after DuPont had pulled out of their work at Hanford. I ran into him when I was sent back. They needed to continue to be sure they always have an active reactor that could be devoted to making the initiator in an atomic bomb, and the initiator, I think, had a relatively short life. And so the government authorized building additional reactors. And Frank got out and got started on this thing, and it just wasn't getting anywhere in terms of meeting schedules like we had. So we were sent out, a small team of us, to work under Frank Creedon to build some additional reactors. I think information you already have indicates that there are 9 there now. We dealt with 3 and then 2 more. So even since we left, they have built more reactors, but the time interval, the pressure has not been on them.
Could I revisit the graphite for a second?
Sure.
Because nobody'd ever machined graphite like that before, had they? And how were you able to maintain such incredible tolerances? I had heard that across the reactor face that there was less than an inch of variation from one side to the other in the machining of those 2,000 blocks of graphite.
Actually, you didn't hear right. I don't think we had that much variation.
Oh, really?
Yeah.
Tell me how much variation there was, and tell me how you maintained that kind of.
Well,
Talk to Cindy.
each block, our blocks came in 4 3/8 inches cross section. Our lattice for the pile, I think, was 4 and I think we were, I don't know, 4 3/16, 8 3/16. And so that meant we had to take off roughly 1/8 of an inch of material. But to answer your question specifically of the how do you do it, or how do we maintain it, the first thing we had to overcome was the ability to make blades that we could put in the joiners. So they were high-speed, of course, the joiner is a high-speed piece of equipment. And they turned through this graphite. The first cut of the graphite wanted to destroy it. Then we had to go on and find out, well, how sharp did we have to get them? How long did we need them? And we had supplies aside. To change, we just changed the whole head. And our tolerances were our biggest tolerance is 5/1000 of an inch. Our our boring tolerances for tubes was the thousandth of an inch. And that was a very intricate job to do too. But how do we make, we had, in order to not have the checking of the blocks become a problem, we scoured the field and found that there was an outfit made what they called an electro check. And the block would come off the joiner, be on a conveyor, go through the electro check, which read, or we actually set it to alarm if the tolerance went out of range. And we could set the range on the electro check